Number 12. At one instant, a bicyclist is 40 meters due east of a park's flagpole, going due south with a speed of 10 meters per second. Then 30 seconds later, the cyclist is 40 meters due north of the flagpole, going due east with a speed of 10 meters per second. For the cyclist in this 30 seconds interval, what are the magnitude and direction of the displacement, the magnitude and direction of the average velocity, and the magnitude and direction of the average acceleration? So the first thing that we should do is draw what's happening so it's easier to understand the situation here. So let's say this is our x direction, which points to the east, and this is our y direction, which points to the north. This is the flagpole over here, so this is the flagpole. So first, the bicyclist is 40 meters due east of the flag, so it is over here. So let's say this is vector A, and the velocity in this point, let's say it's VA, is equal to 10 meters per second. So however, it points to the south, so minus 10 in the j direction meters per second. So this is the vector, the velocity at the first point, and the vector A is just 40 in the I direction meters. So 30 seconds later, the cyclist is 40 meters due north, so it is something like here. So let's say this is our vector B. So vector B is equal to 40 in the j direction in meters, and we have the velocity at this point, which points due east, so points this direction over here. So this is VB, and VB is equal to 10 in the I direction meters per second. So let's just rewrite VA over here. So VA, okay, so the arrow should be here, right? Because it's a vector. So VA is equal to minus 10 in the j direction in meters per second. So this is all the information that we need in this 30 seconds. That's all we need. Okay, so what are the magnitude and direction of the displacement? So the displacement is vector B minus vector A. So B minus A, this is the displacement. Let's call it delta R. So delta R is equal to minus 40 in the I direction plus 40 in the j direction, and this is in meters. So we want the magnitude of the vector, so it is just the square root of each term squared, so minus 40 squared plus 40 squared, and this gives us roughly 56.6 meters. So this is the answer of letter A. For letter B, we want the angle, so vector R is something like this. So we want this angle over here. That's what we want. And the angle is equal to the tangent to the minus 1 of delta R y component over delta R x component. And this is equal to the tangent to the minus 1 of 40 over minus 40. And this gives us, let's say it gives us 135 degrees or minus 45 degrees. So we have two different answers and we have to choose which one is the correct one. So if you see from this draw over here, you see that this angle, it's not minus 45 degrees, it is 135 degrees. That's the answer of letter B. For letter C, we want the magnitude and the direction of the average velocity. So the average velocity is just delta r over delta t. So the vector, so delta t is equal to 30 seconds. So it is minus 40 in the I direction over 30 plus 40 over 30 in the j direction in meters per second. So this is equal to minus 4 over 3 in the I direction plus 4 over 3 in the j direction. The unit is meters per second. So this is our vector for our average velocity, but we want the magnitude of this vector. So the magnitude of vector v is equal to the square root of minus 4.3 squared plus 4.3 squared, and this gives us, let's see, roughly 1.89 meters per second. So that's the answer of letter C. For letter D, we want the angle. So the angle is equal to the tangent to the minus 1 of the y component of the velocity over the x component of the velocity, which is equal to the tangent to the minus 1 of 4 over 3 divided by minus 4 over 3. And this gives us the same answers as before. So 135 degrees, a minus 45 degrees. And of course, the correct answer is this one over here. So for letter E and F, we need the magnitude and the direction of the average acceleration. So for letter E, we want vector acceleration, which is delta V over delta T. And delta V is VB minus VA over delta T. So this is equal to VB means minus VA. So let's see, 10 in the I direction plus 10 in the j direction divided by 30 in meters per square second. So this is vector acceleration. And this is equal to 0.333 in the I direction plus 0.3333 in the j direction in meters per square second. So the magnitude of the vector is equal to the square root of, this is a third, right? 1/3 squared plus 1/3 squared, and this is roughly 0.41471 meters per square second. Okay, so the acceleration, which is the angle of the acceleration, is exactly the same thing as before. So we are going to use the tangent of minus 1 of 1/3 over 1/3. And this is different because we have the minus sign over here. So this is plus 1, this was minus 1. And this gives us two different answers, 45 degrees or minus 135 degrees. So we can just draw this vector over here to choose which one is the correct angle. So we can see that it is positive in the x direction and the y direction. So our vector is something like this. And this vector makes 45 degrees with the x-axis. So the correct answer is 45 degrees.